Our subject matter is not the Milwaukee engineering screw up of the decade that there. So, yeah, I ought to. I put an assignment up, and I'm going to hold off on making that due because looking at the assignment and looking at the rest of the chapter, I realized that this material to do this lab most efficiently, you could do the lab with what I've covered with the while statements, but that's probably not the best way to do it. So I'm going to delay the date on turning this in till after I start chapter 4. So even though the assignment is out of chapter 3, that there is that the for statement would make this problem a lot easier to solve, to use the for statement. Using the while, you end up with some pretty ugly code, and I don't really want to teach you how to write ugly code that there. So actually, it would be much easier after we covered functions, but we won't get to functions till chapter 5. So that there. So I'm going to just jump in here, and I'm going to finish up chapter 3 today, most likely. I'm going to skip a lot of it that there. So chapter 3, where were we? There's a whole bunch of stuff in chapter 3, and a lot of it's just repeat. I don't even remember where we were at. I think we were somewhere around 60, weren't we? Yeah, I think we went through this program right there where we took the average of the grades, where we entered 10 grades. Right there. If not, let me just kind of go through it again briefly. Slideshow, and I gotta remember that my pen never works in this room. Hey, it works today. I have got to figure out the mystery of this pen. That is the greatest mystery of all times, because you've watched me. Some days it works, some days it doesn't. Some days if I use a VGA it works. Some days if I use, today I'm using HDMI and it's working. So to be honest with you, I think it's Windows Update. Yeah, my computer did an update yesterday, and it probably fixed the problem. The next update will probably break it again. So, all right, this is a program that uses a counter. And our counter is right here, right there, where we keep track of how many grades have been entered. And we know ahead of time that we're going to enter 10 grades right there. So we have a while right there. And inside the while, we have our counter is equal to counter plus 1. Now, this is the way that you would solve that homework problem I gave you, is to follow this type of format, but I'm going to give you a better way later on. So what this basically does is for each of the 10 grades, it prints out the printf, and this is showing it as doing a percent string. So it's going to and we place the string. Now you could actually just do the printf and put enter grade and not bother with the percent %s and then the string afterwards. In other words, you can just do and that's the way I think we started off doing it there. We scanf for those who slept since a week ago and have not looked at this. It reads from the keyboard, and it's going to read a decimal, and we're passing it the address of the variable grade. So grade is defined as an integer. We increment our counter and then we keep track of our total right there. We add the grade that we enter to our total. We increment our counter. So this is a loop to enter our 10 grades and total them up. So that there. So anytime you have a function where you need to enter a bunch of data that there and total them up, or that there, and of course our goal is to find the average, and the average is done by just simply saying the average is equal to total divided by 10. Now, I should point out this average right here, because these are all integer numbers here, this average is truncated. If you were to actually average those out, and the slides later on will talk about that, the actual average is 81.7. You know, I used to do some teaching online for a university back in the States and they always truncated the students' final grades. It was an online class, and the students turned in their homework. I graded their homework. I answered their questions. I graded their labs, and they took they took quizzes every week, and then a final exam at the end of the course. And they could have this particular university worked on a 60, 70, 80, 90, scale, the standard U.S. scale, and a student could have a 79.85, and the system would record that as a C. So it truncates that there. So this just kind of explains that right there. So again, this talks about the fact that the actual average is 87. If we want it to be more accurate, what we can do is we can do what they call a cast operator. And a cast operator is basically, this is getting into the fact that, now we'll see on the next section. Okay, I got to follow the slides. I'm wanting to jump ahead of the slide. Now they're getting into the next section here, where we don't know how many students are in the class. We made the assumption that there might be 10 students in this class. Well, let's say we don't know how many students are in the class. And the way we do that is we use what's called a sentinel value, or a value that triggers the fact that we don't know how many students are in there. And usually that's some value that you would never use. In this particular case, we're averaging test grades. If we entered a negative number, so far I've graded a lot of exams. I've given a lot of hundreds. I've given a lot of zeros. Zeros are pretty hard to get on an exam, but I've given some zeros over the years, right there. So, but I've never given anybody a -5 on an exam, that there. I mean, if they don't show up, they get a 0. If they put their name on it and leave everything blank, they might even get 5 points for at least showing up and putting their name on the piece of paper. That there. But so far, I've never given a negative score on an exam. That there. So we have what's called a dummy value at the end, or a flag value, or a sentinel value. I like the term dummy value or flag value. Sentinel is not one of those words that's used in Malay English very much. Dummy is, right? So it's a value that doesn't exist in real life. And if you put that in, that's an indicator that you're done with the data right there. And because so he's using -1 as the sentinel value. So he's going to input grades of 95, 96, 75. In the last grade he puts in is a -1. The -1 is not added to our total, and we don't count that. So we would calculate the average of the first 5. The -1 is ignored, but it tells our loop to dump out right there. And this just gets into there. I'm just going to jump straight into the code right there. He's just talking about the pseudocode that there. So, as I said, I'm going to right here. This is the pseudocode. Hey, I'll talk a little bit about this. You initialize the total to 0. You initialize the counter to 0. Now again, your counter, you don't know how high it's going to go up. Input the first grade. Now, if it could be that the first grade is -1, there are no students in the class. Kind of a dumb reason to run the program. Then while the user has not entered the Sentinel value, add this grade to the running total, add 1 to the grade counter, and input the next grade. Now, notice that we have to put a grade in first and at the end of the while loop. And that is to take into consideration that we don't want to count the Sentinel as part of that there. Because this is how we keep track of how many grades have been entered. Is we started off with the counter is equal to 0. Every time we add a valid grade, we increment our counter by 1. Is that there? So if I put in a -1, this will go back to the start of the while loop and drop out of the while loop. It won't execute the code in the while loop right there. So it's important that you do it in this order. If you don't do it in this order, it won't work properly. So if the counter is not equal to 0, go ahead and divide the total by the counter. Again, we don't know. The last time we put the number 10 in this particular case, it's going to be, it would be 5 in this case, because that's there. If the counter is equal to 0, then you just simply say, you didn't put in any grades, so there's no average to compute right there. So the code looks like this right here. Now a few changes here. One is we've now, for the average, we're using a floating point number. So there's some new information in this slide right here. So we're introducing a new data type, a float. I mentioned it earlier. Here's our total is equal to 0 and counter is equal to 0. One of the things to keep in mind is that when we initialize a value in C, or define a value in C right here, we're setting aside room in memory, and that memory may contain something beforehand. Now, this particular programmer does this in 2 steps. That's probably the cleanest way. I can be lazy, and you can do the line int grade equal 0 right there, where I define the variable grade as an integer, and I initialize it to 0 in the same statement right there. And I can also put a comma and put them both on the same line if I want to. So there are other ways of doing it than what the author is doing. The way he does it is not wrong. It's just there's other ways of doing that there. So float, the average is a floating float. So we're going to use a decimal point number so we can show our 81.7 right there. We do our initial enter grade. There, notice in our prompt we say enter grade and -1 to end. And then we do our scanf to read our grade right there. Then we do, this is the key to this right here, is while grade is not equal to -1, right there, we increment our total and we increment our counter right there. Well, we don't increment. We add grade to the total. We keep adding up the total. Then we get our next grade. So this seems like it's kind of a waste to have to repeat these two lines twice, but you have to if you're going to use the sentinel. Right there. If you don't do this first printf right there, this first one right here, if you skip that one there, the code will still work, except for you'd have to change it around. It will always go through and ask for the first grade and always print an average. So the cleanest way is to do it this way. So, and then the final thing is, if the counter is not equal to 0, if the counter is equal to 0 means that on the very first pass through I entered a -1, so I never incremented the counter and therefore there was no grades there. And we do something a little different here is we place the word float in front of total divide by counter. Total and counter are both integers. So when it does the calculation, it's going to do an integer calculation unless I tell the compiler otherwise. Average is a floating point number. Average is floating point. But I want my answer to be in floating point, and both the numbers I'm dividing are integers. So by default, C is going to look at the fact that I'm dividing an integer by an integer, and as a result, it's going to do integer division on that. Well, integer division throws away the remainder. The fractional part is lost. By putting the word float in parentheses in front of that, I'm telling the compiler to do a floating point operation on it, even though that they're. And then the other thing that I'm adding here is that I'm doing a %.2f. That is the way that before we use %d for decimal, remember %f for %s for strings. Now we're introducing a new one, %f. If I did a %f without the .2 in front of it, then it would just show it as a floating point number with all the digits of carrying out there. So I might have 8 or 9 digits in the answer. By doing the 0.2, I limit the answer to 2 decimal points right there. So that's something new that you need to put in your little memory banks and things to use right there. And of course, if the counter is equal to 0, we at there. And so that's our using a sentinel value. As I said, I'm going to kind of fly through the rest of this chapter and get into chapter 4 right there. And here we're entering that there. Notice that our answer is shown as 82.50. If I didn't use a floating point number for average and the cast operator float, this would show up as just 82 right there. This is showing another run with where we entered just a -1 right off the bat. We didn't put in any grades and just show that there. So this is a program that this is basically, okay, they're just simply saying that if I forget to increment the, without the braces, they're just simply saying that we left the braces out here. There's no braces there. So this is just continuously going to add total, and it's an infinite loop. That's there. So if you did that, you won't get a syntax error, but your program will lock up when you try to run it. He's just showing braces are necessary in this case. And again, The braces are not needed if you've got a single line, but just get in the habit of using the braces. It just makes your life easier if you always use the brace. And then you tab in all 4 lines would get tabbed in, and the brace would be by itself at the end right there. Which is shown right here. These see how these are all in a line there together. They're all indented right there. And then the closing brace is underneath the while right there. He puts the opening brace here, that's perfectly fine. But the closing brace goes under the while, and everything in the while gets indented to the right. That makes your code a lot easier to debug and find errors in it. It's just one of those, it doesn't, you don't have to, indents are ignored, compiler don't care, you don't have to do it, but when you're sitting there given a problem like the one I just gave you, and you're sitting there trying to debug it, trying to get it working when you're in the hospital at 3 in the morning, and it's due at, it was due at 12, but you're still working on it at 3, and you're trying to find these errors, those indents make a big difference right there. So then I mentioned the fact that the floating right there, and again he talks about the fact that the truncation, if it does the integer, the fractional part is lost, and by using the float in the parentheses ahead of time right here, that causes the compiler to keep track of the floating point there. So the rest of this is all right there. So S operator, and then he talks a little bit about the percent too, and I mentioned that already. And he talks about %1. You can show as many decimal places as you want. You can do that there. And I'm going to skip through this particular one. This is one you can read. You've got an assignment that you'll be working at there, but this is just, similar that they're students that last year 10 students completed that they wants to know how else did on the exams, and then you're supposed to keep track of, next to each name you write a 1 or a 2 if the student passed or failed, input, and it just keeps going on and on right there. And this is just an example of another example. I'm not going to go through it step by step. It's very similar to the previous one right there. It's worth it for you to look at it. You've got the slides up there. And a result pass up there. And all it does is just keep track of the number of passes or fails. So every time someone puts in a 1, it increments the pass. Every time someone puts in a 2, it increments it. And this one here, 90% passed, so the instructor gets a bonus. I don't know what it is. I never got a bonus when I had student pass the PE exam and things like that. Okay, I'm going to kind of finish up this chapter. As I said, I was going to finish this chapter today and then start that there. C has what they call the assignment operator. And what it is it's the authors of the C language decided that life wasn't difficult enough, so let's put in some cryptic syntax to confuse everybody else that's not in any other language. Right there. And that's what these assignment operators are. So here I've got the statement C is equal to C plus 3. And the C language, not to be confused with the variable C here, has what they call a short version of the assignment operator, where I can say C plus equal 3. These two statements are equivalent in the C language. The first one, I understand what it means, right? Everyone knows that if I say C is equal to C plus 3, if C is equal to 5, after this statement is executed, C will be equal to 8, right? The statement C plus equal 3 isn't quite as clear as it's the same right there. But as I said, these assignment operators are the result of somebody probably sitting around drinking too much Mountain Dew or Red Bull, at 2 in the morning, putting this language together, trying to come up with ways to save time right there. And they came up with this idea of the shorthand version of the assignment operators. There's no advantage of using them. The compiler is going to optimize your code regardless of what you put in it. So if you put in C is equal to C plus 3, or if you put in C plus equal 3, when the compiler takes your code and translates it into machine code, it's going to translate it into the exact same code. So there's no advantage of using C plus equal 3, but there's no reason not to once you get used to the syntax. You might as well save 1, 2, 3, 4, 5 keystrokes. 1, 2, 3, 4. You save 1 keystroke right there. You save typing the letter C a second time. You still have to put the plus in. You still have to put the equal in there. You just save one keystroke. Now, if the variable names are longer, then of course you're going to save retyping the variable name. That there. I grew up in the life before C. My first programming language was Fortran, then followed by BASIC, and not Visual Basic, but Standard Basic, and then my third language was Pascal, and then after Pascal was PLM, and then JCL, Job Control Language, and then finally C, like maybe my 6th language. So, so I didn't grow up, wetting my teeth, cutting my teeth with C. So, these cryptic add-ons to C kind of baffled me at first. Now I use them. I'll be honest, I'll use them. So, and you could do that with any of the operators. C plus equals C minus equals C times equal C divide, or integer divide. There, you can do it with all of them right there. So you can see that they're all there. And what you have is you have the operator and then the equal sign right there. So if I have C times equal, or excuse me, C times equal 20 right there, that's the same thing as C is equal to C times 20 right there. So, and you can see all the various examples right there. So, all that there. Again, you can use them. There's no reason not to, but you don't have to use them. My recommendation for somebody in a first-time programming class that's not used to programming is that you don't use these assignment operators, because it's easier to follow what your code's doing and what's going on and debugging if you don't have this cryptic shorthand right there. Now, if that's not bad enough, we've got the increment and decrement operators. And this is really, and I hate to say this, but I suspect the people who came up with this idea might have been drinking more than Red Bull at this time, or they might have been smoking something other than cigars right there. But they've come up with this concept of doing plus plus A plus plus, minus minus B, B minus minus. Now, the order in which I do these make a difference. But A plus plus is the same thing as A is equal to A plus 1 right there. Right there. But where things get really interesting is I could put this in a formula. So in the formula, two things happen. One is I'm doing a calculation. And then the other thing is I'm incrementing A. So I can say C is equal to 3 times A plus plus right there. That is the same thing as saying C is equal to C, or excuse me, C is equal to 3 times A, and A is equal to A plus 1 right there. So I'm doing two things in the same statement. Now where things get interesting is I could take that same line, where's my Milwaukee River? I must have closed it. Right there. Lake Michigan. I can say C is equal to 3 times minus minus A right there. Or I can say C is equal to 3 times A plus plus. Let's make them both minus minus right there. Right there. Now this translates to A equals A minus 1, and C is equal to 3 times A right there. Right here. This is C is equal to 3 times A, and A is equal to A minus 1 right there. If I put the minus in front of the minus in front of the A, it does the subtraction first, then does the multiplication. If I put it afterwards, it does the multiplication first, then does the subtraction. And you can see where I'm saying that somebody was definitely drinking something other than Red Bull when they came up with this syntax and this up there. It's very powerful. I mean, you can really, really shorten your code, but you could really, really write some code that's impossible to understand what's going on. Because I'm doing two things in the same statement. Now, if I'm doing a for loop or something where the A minus minus is by itself, or the A plus plus is by itself, that's fine. But when I'm including this in a formula, then it gets really interesting. Now, it's powerful when we're dealing with arrays because I can tell it to read an element of the array and then increment it for the next element of the array within that there. So, but it's just simply a case where we've got the plus plus and the minus minus. These are two increments that they're, but if we put the plus plus in front, that means that we're going to add 1 to the value, to whatever the variable is, then use it in the formula. If we do it afterwards, we're going to use the old value in the formula and then add 1 to it. So whether it's in front or behind makes a difference in your code. That there, and I'm just going to say this is a case where the syntax actually starts getting really ugly and hard to follow. I mean, the plus equal is bad enough. Times equal is bad enough. But as soon as you start doing plus equal and then do plus plus, I mean, you could actually have a statement that says K is equal to K plus equal, and I'm going to say A plus plus right there. So, I mean, what does that mean? Well, that translates to K is equal to K plus A, followed by A is equal to A plus 1 right there. That's the translation of that code. Or I could have K minus equal minus minus B right there. So now this is B is equal to B minus 1 and K is equal to K minus B right there. It's not obvious looking at that K minus equal minus minus B. What in the world does that mean? Right there. And as you recall, day 1 or day 2, I mentioned that I would not normally use C as my first programming language. And this is the kind of syntax that scares me with first-time programmers. Because you start using this in your code, and you have problems in your code. Where is the problem? When do I do the plus plus before or after? Right. Now I will use it in the for statement, but when I use it in the for statement, it's in a single statement right there. Because if I have a statement A plus plus by itself, which is A plus, A is equal to A plus 1, or if I have plus plus A, that's still A is equal to A plus 1. Because it's not in a formula, it doesn't matter whether the plus plus is before or after. And if I just see the plus plus or the minus minus, I know that that's an increment or decrement up. Where the problem comes is where I'm starting to use it in formulas. Right there. That's when it becomes, the syntax becomes really messy right there. So again, he goes through an example here where he does the printf, he does the C plus plus here, and notice that here he's doing it in a print statement. Here he's going to print C, then increment it. Here it's going to increment it and then print. So in one case, it's going to print 5. In the other case, it prints 6. So, depending whether you put it before or after, got there. And I showed, it's nice and easy in a print statement. It doesn't really matter that much. But when you're dealing with a formula, it can make a big difference. Right there. So, that there. And again, he's showing that in his example program, he used passes is equal to passes plus 1, failures equals failures plus 1. He says that he could have wrote that as passes plus equal to 1, or he could have used plus plus passes. That there. And because these 3 lines in that code, and this is that program I skipped, because those lines only contain passes equals passes plus 1, it doesn't matter whether I use post or pre increment right there. The problem comes in is when it's in a formula. This is not a formula where I'm using the term using passes other than to add 1 to it or right there. So this particular program actually is not that confusing if you were to go through it. It's only when the variable, again, this is going back to what I was saying. It's only when the variable appears in the contents of a larger incrementing process has different effects. It's only when it's in a formula that's there. So, but the simple expressions set there, it doesn't make a difference, but it can make a difference in a larger expression right there. And I think I'm going to skip all this stuff here. This is talking about using the plus right there. And I'm going to kind of skip all that there. And I'm going to skip everything here on the secure. All right. I want to jump to chapter 4 for just a few minutes. How am I on time? 40 minutes. Okay, I got time. Jump in chapter 4. And then tomorrow I'll talk about the assignment right there. So, and as I said earlier, I could have spent half of a course on chapter 3. Chapter 3 covered a lot of material. Chapter 4 is not nearly as bad. Right? So, and why are we not? Okay. We're going to learn basically three or four different commands here. The one that I'm going to concentrate on is the for statement. That's the one that I'm going to talk about today. We'll come back and then I'll talk about the assignments in where using the for statement makes doing that assignment much easier right there. And then I'll also talk a little bit about this floating class quiz assignment where I give you that there. The do while, I'll spend a little bit of time on that, but the do while is one of those formats that's not used very often. Then we'll talk about the switch to replace the if else, multiple if else, and then the break and continue operators. We'll just kind of mention those right there. But right there. So this is just basically talking about what's covered in the chapter. So again, we're dealing with loops. And loops have two ways of ending the loop. One is using a counter, and the other is using a sentinel or a dummy value to end it. We got there. Now, counter-controlled iterations are definite iterations. In other words, we know how many times we're going to go through the loop, or we have an idea right there. There's an easier format than using the while. And so we have a control variable used to count the number of iterations right there. Precise number sentinel values is just repeating what was covered in the last chapter right there. So control there. We have an initial value, we have an increment or decrement value, and then we have a final value. We have three things when we're dealing with a loop that's of a precise number of that there. So for employees, for 1 to number of employees is a variable, we could use that there. We can have a variable right there. We can go for each that there. We can go for 10 students. We can go for 20 students. We know how many students are going to be there. Now, as it turns out, we don't necessarily have to. We can ask the user to enter how many students there are and use that as our ending value. We can use them. They haven't talked about that. But here, again, and this must be the dad's old code, unsigned int counter is equal to 1. So he's declared a variable as an unsigned integer, and he's initialized it to a value of 1. And remember, some of the code would have just int counter and then have counter equal 1 later on in the code. This is the first time we've used the syntax unsigned int, which means it can't have negative values right there. And there's some advantages if you're dealing with a small microprocessor to use unsigned, because it takes up one less bit in the number right there. So right there. And here we have an example of something that counts from 1 to 10, right? We run this right there. We initialize counter is equal to 1. And we say is while counter is less than or equal to 10, print counter, and then increment the counter. And notice that he's using the plus counter syntax right there. Now, there's an easier way of doing that right there, and this just kind of explains that. Right there. Now, one of the things he's done here is he's stuck the plus in there right off there. Now, if in order to do this, he initializes it to 0. He could actually initialize it to 1 and you put the plus afterwards. Right there. But this is what he's showing here is that he's doing the plus in the while statement right there. So that eliminates this line here in the loop right here. This line disappears by simply putting a plus, and I'm going to put it afterwards right there, plus there. But you can, if I put it afterwards, I can leave the counter is equal to 1 right there. So right there, by putting the plus, we save a line of code. Is it worth it if you can't figure out what's going on in the code? Now, there happens to be a syntax, a statement called the for statement. And the for statement is designed specifically for loops that have a initial value, a final value, and an increment or decrement value. So you'll hear me use the syntax for next because that's what BASIC and Fortran used. But C dropped the word next just like it did the if then statement. They dropped that there. So what the for next loop right there here is, and this is a case where he does all kinds of things here. I would not do this here. I would not do the I would do the initialization outside that there. However, there is an advantage of doing the initialization at the top of the loop like that inside there, in that C is smart enough to know that counter only exists within this loop, and when counter ends, or when the loop ends, counter is taken out of memory. It's gone. It's lost. And memory is freed up. So there's an advantage of doing it this way. It just makes things a little harder to read. But what we've done is we've assigned counter is equal to 1 as our initial value. This is our final value, our test right there. And this is our increment right here. So that definitely shortens that program right there. Now, you'll see some people write this as 4. I put a semicolon, and I put a semicolon, and then I put that, and then I put a bracket at the end here, and then I put my end bracket right here. This is my initialization, this is my final, and this is my increment right there. Those three things, increment / decrement. right there. Those are the three things. And early in the semester, I tried doing a program, and I got two of them mixed up right there. You know, for whatever reason, they put the final as the second, where I would have done, if I designed the language, I would have put the order differently. But that's the for next loop right there. And it's easier to use than the while if you have a definite counter right there. And you can put anything you want in the initialization. You can put anything you want in the increment or decrement, and you can put anything you want in the final. It's just the final is a Boolean expression that evaluates the true or false. If it evaluates as false, the body of the loop is then skipped. If it's evaluated as true, the body of the loop is executed one more time. On your counter plus plus, your increment, I can say counter plus equal 0.5. I can say counter minus equal 0.25. So I don't have to increment and decrement in values of 1. And I can put any executable statement there. I can say counter equals counter times 3. That there. Now I could put nothing in there. I can just leave these all three blank, and it'll just keep running forever. Right there. You don't have to fill in all of them right there. You could leave the increment and decrement blank if you want, and just have a final value in there where it's looking for something, a sentinel inside that there. But you will see, and the reason I wanted to go through this specifically and not much more detail is that I'm going to tomorrow go through the assignment I gave, and I'm going to do the first part of it for you right there. And then if you look at the assignment, you'll see that the first part is reused in the second two parts right there. But I don't want to talk about the assignment until tomorrow. But in finding the factorial, it's really easy at there. And I'll just kind of, right there. When we do the factorial, it's fairly simple. I'm just going to use f as my final value. I'm going to find factorial n plus plus, and then I can simply say n is equal to n times I need a total. And I'll do this tomorrow and test it, make sure it works right. But right there. And that should find the factorial. Because the first time through the loop, let's see if I put in 5. The first time through the loop, n is going to be equal to 1. So it's going to be 1 times 1. Second time, n is going to be equal to 2, so it's going to be 2 times 1, so it'll be 2. The next time it's going to be 3, so it's going to be 3 times 2, or 2 times 3. Then the result of 3 times 2 is 6. The next time it's going to be 4 times. Then finally 5 times right there. So this is the code to find the factorial. We'll test that. And you'll have to use that every time you want to find the factorial for the other equations. Right there. Now later on we'll write a function called factorial where we call factorial. Here we'll have to stick this inside the body of the loop right there. So that there. But again, we'll talk a little right there. So again, this kind of goes through and explains what I was talking about. Right there, goes into more detail. Right there, 4 does it all. And this is a good slide in terms of explains what's going on right there. This is a good slide. And again, normal logic would be that I would not I'd assign the counter when I assign all the other variables, but by assigning it within the loop, that makes it a localized variable just for this loop, and it disappears. And I can use the counter variable again for something else if I want to. In other words, it disappears. It's only valid within the body of this loop. It's considered a local variable right there. And they talk about one-off by errors. Again, this is the general format, visualization, the condition, and then the increment statement right there. And come on. That there. If we leave the condition out, it assumes it's true and it just runs forever. Increment can be omitted right there. So the 3 statements that there, when we look at this right here, initialization, condition, and increment, those are optional. Normally, for right now, for any kind of for loop, we would use those. But I've done statements called for right there. And then I have the opening bracket and then the closing bracket. That actually is an infinite loop. That's the same thing as, while 1 equals 1, or while 1. Now that's just another way of doing an infinite loop right there. And they talk about that. And the increment X is a standalone. So all 3 of those, 4 of those are the same. And I think I'm going to, they get into some more complex ones here. Here we start off with J is equal to 2. We go until J is greater than 80, and we increment by 5 every time. Here we say initialize J is equal to X, and then we say J is less than 4 times X times Y, and then we say J plus equal X divided by. So again, they're showing that these can be more complicated statements than just a very simple one. For now, keep life simple. I mean, that first one right there, I challenge anyone to try to figure out what's going on in the scope of a larger program there. I mean, unless you're a fairly seasoned programmer, doing a J less than 4 times X times Y is, what in the world does that mean? And I'm sure it means something, and somebody uses this and that there. I've actually used something as ugly as that, but at this stage, keep it more like the second one. Right there. And I think I will wrap up. I'm right at my hour.